All right, so thank you everyone for joining today. Happy to see that many of you have chosen to register to our fifth now webinar since we started. The topic for today is user variables. We've received new ideas for some of you, and thank you for that. Please keep sending us your topic through our website. So we'll do our best to address all the topics. So last point before we start, as mentioned also in our email, we want this webinar to be as interactive as possible. So please do not hesitate to use the chat feature to ask your questions. Since we have muted everybody, we will monitor the questions and answers on the go. Today we'll have an overview of what is already available in our database in terms of user variables, see how to use them, and how to create a user solver. We will not address how to create your own user variables from scratch today. This is obviously a lot of work, and this requires dedicated training to your specific user variables, because as you can imagine, it covers a really wide range of different subroutines that can be done. So this will not be addressed today. If you're interested, please contact us to schedule an online training on that. Now, I'll let Sergio lead this webinar. He's a technical support engineer at Transworld America. Sergio?
All right, thank you, Nicolas. Good morning, everybody. Hope everybody's staying safe out there. As Nicolas said, we're going to cover today the concept of user variables and all the concepts around it. All right, so we're going to start with a quick introduction to review the concept of user variable. Then we will show the default user variables that we have in our software. Some of them are not really known, and I would like to review the most typical ones. Then I will show how to implement customized user variables that can be created by the users, or they can be provided by our support team. And finally, we will review the new Python console, and we will clarify what we can do with it and the main purpose of it. All right, so let's start with an introduction on the concept of user variable. User variables are additional variables that are created to address very specific needs for users. They are created combining the existing results in our software, and they are extremely customizable. You can combine the existing results that we get by default in any way you need. To access them, you have to go to the billet in the interface, properties, and then user variables. I will get into detail in the store section to see the default user variables. In case you have a customized user variable that our support team has provided or that you have created on your own, you will have to use the disk option. We will get into detail about this later. First, we need to introduce a really related concept to user variables, the user routines. Once we have decided what we want to do with our user variables, we will need to compute them through user routines. These are the coding created to define the user variable. They are coded using Fortran coding language, so you would need some knowledge on this type of coding language or a dedicated online training performed by our support team again. Otherwise, it's really complicated to create your own user routines, but it can be done. Please contact our support team if you are interested on that. I'm not going to have time to get into details on how to develop your own user routines. But it's important that you understand that the user routine is the additional code that we're going to add to the default code in the solver to specify what we want to do with our user variables. Once we have prepared our user routine, we will need a Fortran compiler to create a customized dynamic library. This is what we will use to add in our Transvalor software in Forge or Faircast. This is what we will use to add this additional coding. Okay. This dynamic library will be imported using a user solver. Again, I will explain this in detail later, but it's important to understand the basic concept. User variable, user routine, and dynamic library. Those concepts are going to be mentioned several times. Please, again, I want to emphasize that our support team, we will assist you with all this, and we can create user routines on demand based on customers' needs. So please start the conversation if you think that you could take advantage of this feature. Okay, first, we're going to start with the default user variables. Through the years, we have created several user variables and their user routines to address different customers' needs. These user variables are implemented by default in your installation, so there's nothing to be done in terms of creating the coding needed in the user routine. All you need to do is import the default user variables. To do this, we will use the store section. So again, you have to go to properties, user variables in the billet. Clicking in the store section will open this menu, and you will find different groups of user variables. All these have been coded by Transvalor, so there's nothing you have to do other than import the user variable here. We have several groups. Basic has the most commonly used user variables. Damage criteria will have all the criteria for damage that we have developed during the years. There are a lot of different options. We'll show some of them later. Metallurgy has a lot of user variables related with temperature, time, and strength combinations. It has some element diffusion variables, a lot of things there. We will review the most important ones. Miscellaneous has all the user variables that don't fit in any of the other groups. And there are a lot of very specific parameters in there. Those are the 4 I will review in detail because they are the most extensive. The others are a little more specific. Please, if you have any questions about any of the user variables, again, contact us to our support email, and I will be happy to develop and review any of them. I want to mention the where category. In our last webinar, we talked about the RCards model. Here is where you will find the user variables to implement this. So please review the recording for where analysis if you want more details on that. Also, I want to mention the user group section here. This is where you could import in your store or your installation all the customized user variables for your company. You can use the store manager option or feature to implement your own user group. And yeah, again, the user routines for the default user variables are embedded in the default solver. So there's no need to import anything or create a new user solver implementing the new dynamic library. There's no need to do that. The only step required is to load the user variable using the store option. Okay, so now let's talk a little about how user variables look. I'm going to start with the basic group. Here we have the most commonly used. For example, the last and cockroach normalize is the default damage criterion we use for damage. The main purpose of this variable is to remove elements in piercing or shearing simulations. There's a lot of confusion with it, so I want to clarify that. The main use of this is to remove elements in simulations where we are going to do a piercing or shearing operation. This variable is the only one applied by default in most templates. So you will see it if you go to the user variables in most simulations, okay? You don't need to use it unless you want to apply a trimming or shearing operation. So feel free to remove it if you are not interested on removing elements. And this is how it looks. Most user variables won't require to enter any parameter. You just have to import the value and the user variable and confirm. And you will see the result at the end of your simulation. It will be in the results section. Another example is the principal stress. We can calculate any of the principal stresses. And again, it's just importing the value. Here we have sigma 1 maximum and run your simulation. You will find the result at the end with the other default results. Another one in the basic category that is quite used is the Vickers hardness. This is gives an estimation for the Vickers hardness based on the equivalent stress, how it increases based on the stress in the path. In this one, we will need to add an initial value, for example. So not all user variables are just import and confirm. Some of them will require some parameters or calibration. In this case, the Vickers hardness will require the initial value to start calculating the result. Okay. Now, damage criteria. Here we will have all the damage criteria that are not included in the basic category. This means everything but Lachlan Cockroach and Ojan criteria. These laws are a little more specific, so normally they will be a little more complex. I have taken this example. First, the Maitre criterion. As you can see, it's a little more complicated and it requires some parameters that will have to be calibrated for the model to work. How to calibrate these parameters, you can find this in the literature normally, but again, please contact our support team and we will assist you with it. Okay, next, metallurgy. Here we can find, for example, the carbon rate. If we want to work with element diffusion parameters, we have some useful user variables related with temperature. For example, we can obtain the maximum or minimum temperature in each node. We can have the cooling rate between two temperatures. And one of the most used is the time effective strain and temperature correlations. For example, we can get the seconds that every node has been above or below a certain temperature, time between two temperatures, the strain increase after a certain temperature. There are a lot of user variables here that have been implemented based on customer needs. Here I have an example. For example, in some cases, it's really important to know how much time we have spent between two critical temperatures in our simulation. So we created a variable for that. In this case, we will have to enter the two temperatures we want to use to start counting the time and just launch. This will give us cumulative time between these two temperatures. Okay. Moving on, the miscellaneous section has some really interesting user variables. For example, the alpha X and epsilon, this will give us as a result in our billet the thermal exchange coefficient with ambient media. This is really interesting for quenching simulations where we are using a law for the thermal exchange with the ambient media, for example, based on the surface temperature. This means the thermal exchange will be changing in our part pretty often. With these results, is it possible to visualize how the thermal exchange is behaving? And it will prove to be really useful in a lot of quenching simulations, for example. There's nothing to calibrate here, just import the user variable and launch. You will get the alpha parameter, which is the thermal exchange with the ambient media, and the epsilon parameter, which is the emissivity. Another one here that is quite used is the maximum shear stress. You have the formula here, the equation here with the first and third principal stress. We can show the contact time and the cumulative distance while in contact. These are used for lubricant analysis normally by customers. We can show also the average strain rate, reduction radio. We can show the velocity in cylindrical coordinates. In some simulations, this is quite useful. And then you will find a lot of very specific parameters in this category. For example, the center hormone parameter, the green Lagrange stress tensor. So this is just an example to show that a lot of really specific things can be found in this category, but also a lot of useful things. All right, with this, we have done a quick review of the main user variables. Now we're going to talk about customized user variables. You can imagine this happening if we provide a user variable that you have requested from us, or if you have created your own user variables and your own user routines associated with them. We're going to talk about the main steps to implement these files. I am not going to explain how to create both user variables and user routines. This is once they have been created. Once we have the required files, we will have to follow these 3 steps. We'll have to register a user solver. This is what we will do to implement the subroutines, the coding behind our user variables. Once this is done, we will import our customized user variables in the interface the same way that we do with the default user variables, but we will use the disk option to import our own file. Once this is done, we just have to select the new created user solver when we launch the simulation. We will review these 3 steps in detail later. Here, I have added some notes just to review the concept of user variable, subroutines, and the dynamic library, because it's a little confusing when we introduce this concept. Once we have decided what we want to do with our user variables, we will need to code these in the subroutines. If we don't import the subroutines, the user variable will not work and we will get a crash. To implement the subroutines, we use a dynamic library. Okay. This dynamic library, or DLL file, is generated using a Fortran compiler. We will require Fortran coding knowledge and a Fortran compiler to generate the DLL. Once we have the DLL with the code created for the user variable, we will import all this information in Transvalor software, in Forge, Faircast, Coldform, using a user solver. I will show you now how to import the DLL and create your own user solver. And again, remember that our support team can help you generate this dynamic library according to your needs. If you think you are in position to work with the Fortran compiler and create your own user routines, I just want to mention where the default dynamic library is. It's in the default installation folder. This is an example for Forge. It's in user F3 if we are working in 3D. If it's 2D, you will have to go to F2. In sources, you will find the dynamic library, and in user projects, you'll find the user routines. Inside user projects, you will have the files you need to open with your Fortran compiler. This is where you start. Again, remember that this requires training or Fortran coding knowledge. I wanted to mention this because it's really important that you create a backup copy of the default dynamic library before editing this with your Fortran compiler, just to make sure if you do something wrong, you don't mess up the installation. So always create a backup copy for the default dynamic library. Okay, moving on, I'm going to start explaining how to register a customized user solver. In the new interface or general user interface, this is done in the backstage section, Computation Manager. Once there, we'll have to select Define User Solver. Here, it's important to note that user routines are different for 2D and 3D. So first thing we have to do is decide the dimension. In this case, it's 3D. Then we'll have to name our customized user solver. The name is not important, just don't add blank spaces or special characters on it. Then we'll have to import the DLL. This is the dynamic library with the subroutines, with the code that defines our user variables. Here we will have to import the file created with the Fortran compiler or the file provided by Transvalor support with the subroutines that we have requested. Once this is done, we can add the new user solver and confirm. It's required to do both, add and confirm. Now, in the launcher or all the interface, this is done in the computation section, register user solver. Here we will have the same options, just in a different way. We'll have to select the dimensions, give our solver a name, and import the dynamic library with the subroutines for our user variables. Once this is done, we can prepare our simulation, and we'll have to import the customized user variables before launching the simulation. In this case, we will use the disk option normally to import the file that we have provided or that you have created. You can add as many user variables as you want. Just remember to import them separately. Here you will have a drop-down menu. I've seen sometimes people importing all the variables here in user variable 1, and you will be just keeping the last one you imported. So just remember to use the drop-down menu and import them in separate user variables. Okay, once this is done, all we have to do is save our simulation, and before launching, we will change the solver from default to our newly named user solver. This is in the new interface. in the launcher or on the interface, the option will be here. Instead of default, select the user solver. This will run the default solver plus the additional subroutines we have added for our user variables. Okay, so with this, I'm going to conclude the user variable review.
Sergio, we have two questions before you move forward with the Python console. So let me read the questions. One is from Roberto Frieza. For the time between counter variables, does it use the maximum counter on the billet, or can it specify to a sensor? So I can take that one on, Sergio, unless you want to go ahead.
Yeah, it's fine. You can answer.
Okay, so with the user variables, you will not be able to use results from a sensor. So you'll have to be either, it doesn't have to be a maximum counter. It can be an average. It could be a minimum counter, but it has to be like a result that you will have at every increment. Okay, and that's specific point. Okay.
I want to clarify there that these user variables are shown in every node or every element in the model. So this will be calculated everywhere in the billet, okay? And the temperatures are specified by you. So it's not going to use the maximum temperature on the billet. It's going to go to each element or each node and start counting the time once you reach the first temperature until you reach the second temperature.
That is correct.
But,
okay. Okay.
Okay.
Yeah. So it can be done different ways, but you're right. It is calculated per temperature at each node. So you'll do that. Now, if you want to use a general temperature from your billet for any other purpose, for different variables, you cannot use a sensor, but you can use like an average or maximum temperature within the billet at instant T, at T time, basically. All right, second question is from Rochan Meta Indimet. Is there more in-depth documentation for each of the user variables, specifically how it applies to simulation results? You want to go ahead, Sergio? You want to change it?
Yeah. At the end of the presentation, I will show where you can find a document with details for each default user variable. So please stay tuned to the end. I will show you where to find this information.
All right, and we actually have the third question from André Pillon, McMaster University. Can you use the user variables to influence the solution result?
Yeah, so the user variables are additional code that will use existing results. So this means the default results will not be affected by the user variable. So normally we will create new results. We will not modify the existing results. That's the normal workflow.
Yeah, just one thing on that. In more complex user variables, you are able to loop on the material behavior, for example. Okay, so the consistency of the material, you are able to modify. Let's consider recrystallization, for example, and you want to couple that to local modification of your material behavior. You will be able to do that. It is complex, not as simple as let's say a default type of user variables, but you can do it. But most of the time, yeah, user variable, we use the result. You get temperature, stresses, strain, etc., to create an additional result, basically, that you will look into the interface. Okay, and you can also use it in the sensor, will be exported in that. Okay, Sergio, you can go ahead. That's it for the question so far.
All right, so in the couple of minutes we have remaining, I'm going to explain what we can do with the new Python console, because there's been a lot of confusion about it. So let's go ahead. The Python console enables to use mathematical operations in any scalar, vector, tensor, or displacement that we see in the results section. Any result that you can visualize, you will be able to use the Python console to modify it. For example, this allows us to change the units in a result. For example, changing Celsius degrees to Fahrenheit degrees. We could do this with the Python console, but it will not modify how we calculate the results in the solver. The only modification this will do will be applied to the final results, the existing results. Here we can use any Python command that is created by default in Python libraries, especially in the math module. We can apply any mathematical function that is there. To do this, it's required to have some Python coding language, but it's not required to use the Python console. We can use scripts. So if you open the Python console and click in scripts, you will find a lot of predefined. You can just click on them and they will be applied, okay, in the result that you are visualizing. For example, conversion C to F will transform the Celsius degrees in Fahrenheit degrees for the temperature. That's one of the most used, and it's a good example of what we can achieve. It's good to change the units in our results. For example, imagine that you have a part with symmetry, let's say half symmetry. The tonnage that you visualize there will be only half of the body. So if you want to duplicate this, you could use the Python console to multiply this result by 2. There are several applications, but again, this is only applied with existing results. To open the Python console, it's only applied in the new interface, in the general user interface. You can right-click in any empty space, and you will find it as a window. Okay, it's normally on the bottom right. The scripts I mentioned, they are located in the resources folder in the installation default installation folder. We can edit these with a text editor and use them as templates. This way, you don't require that much coding language. You can use existing scripts to create your own. You can, of course, contact us with any questions you have about them. And in future versions, this will be expanded, of course, and we will have more options. But as of right now, this is mostly used to modify the units in the existing results or to multiply them by any factor, but not to modify anything else. Okay? I don't have a lot of time to get into this in detail, but there's a new dedicated online help section for it, and it's in features, Python console. You will see some examples to create your own scripts and to apply them and see real applications for this feature. And now I just want to, as I do in every webinar, I like to emphasize the online resources we have available for everybody. The online help is being updated weekly. Yeah.
Sorry to interrupt. We have another question from Roberto Frieza. Can the macros be used to apply various Python scripts at once?
The macros right now are not, the application of macros now, it's limited for the simulation name. In the next version, you will be able to use macros to apply several Python scripts at once. But as of right now, I don't think this is an option. I will double check and get back to you on that, Roberto. I will get back to you later today because I don't think you can do it right now. But in the next version, I think it will be implemented.
Okay, thank you.
And as for the other question related to details on the user variables, in the default user variables, you can find it in the reference documentation. Part 8 there is dedicated to user variables exclusively. And you will have details about all the inputs and outputs in each variable and a short explanation about what they do. The reference documentation is in the default installation folder, documentations and reference. And especially in this case, online trainings, especially for user variables and user routines, a quick online training will really help to interiorize the concepts behind it and to start creating your own user routines. Please contact us if you are interested in this, and we will try to customize the online training to your needs as much as possible. And with this, we are done for today's webinar. So if there's any additional question, please go ahead. I would love to answer any questions. Otherwise, thank you for listening.
I thank you, Sergio. I think we are done with questions so far. So thank you all for being with us this morning. I hope you have enjoyed the webinar. We have recorded the webinar and we'll have it available for you in our member area. If you have not signed up yet, please go to www.translatorusa.com and click on Members tab. Then sign up and we will accept your request shortly after. We will communicate when the video is available. We are still working on the topic for our next webinar. We take into account your input and do our best to include them in our webinars. Our next webinar will be held in 2 weeks, on Friday at 10 a.m. Central. We'll keep this 2-week pace for some time. We'll send the email announcing the new topic at the beginning of the week the webinar is held on schedule. In the meantime, do not hesitate to contact us. Should you have any questions, please stay tuned, and thank you again for joining. Have a good day.